In this lecture, we're going to transition into the patrol state from the return state. The return state will always be the default state. If the enemy can patrol, they should start their patrol the moment they've reached the start of the path. We're using the set destination method to accomplish this task. Unfortunately, Unity doesn't make it easy to detect when an agent has reached its final destination. We'll have to perform a few checks before verifying that the agent has finally finished moving. To get started, we should update the patrol state. Open this file in your editors. We should verify that the state has been entered by logging a message to the console. At the top of the file, add the Unity Engine namespace. Without this namespace, we won't be able to directly use the debug class. Next, inside the enterState method, call the debug.log method with the following message: patrol state entered. After adding a message, we're ready to transition into the state. Let's look at our visualization to understand the transitions. The return state will transition into the patrol state. However, the patrol state will not return to the return state. During the enemy's patrol, we should be on the lookout for the player. If the player is detected, the enemy should transition into the chase state. Eventually, they will return to patrolling because the chase state transitions into the return state. After returning to the start of the path, the enemy will resume patrolling. The first step is to create a method for verifying an agent has reached their destination. They shouldn't be able to transition into a new state until we've confirmed their position. Let's modify the movement component to define this method. At the bottom of the class, define a public method called reachedDestination. The return value for this method will be a Boolean. By calling this method, other components can grab the status of the agent's pathing. Within this method, let's return true. If this method returns true, the agent has reached their destination. This statement should appear at the end of the method. Let's create a series of conditional statements. Like I said before, Unity doesn't make this process easy. We have to check dozens of variables. At the top of the method, create a conditional statement with the following condition: agent.pathPending. If this variable is true, let's return false. By calling the setDestination method, Unity generates a custom path for the enemy. This process uses AI to determine the shortest path to the destination. A path may not be generated immediately. It does take time to calculate the best path. The pathPending variable is defined on the agent component. If the AI is calculating the path, we can assume the agent is not at its destination. Hence, we're returning false. Let's add another conditional statement with the following condition: agent.remaining distance greater than agent.stopping distance. If this condition is truthy, let's return false. The remaining distance variable stores the distance from the agent's current position to their destination. As for the stopping distance variable, an agent may not always be able to reach their destination. A threshold can be set for stopping the agent. If the agent is within a minimum distance of the destination, Unity will stop the agent even if they're not exactly at the target position. In this condition, we're comparing both values. As long as the remaining distance is larger than the stopping distance, it's highly unlikely the agent has stopped moving. Let's add one more conditional statement. The condition will be the following: agent.hasPath or agent.velocity.square magnitude $!0f. The hasPath variable can help us detect a path on the agent. If an agent has a path, they're moving around the map. Therefore, we should return false. I'm introducing a new operator called the OR operator. It's written with 2 pipe characters. We're not limited to writing a single condition. Multiple conditions can be chained within a single statement by including this operator. The second condition checks the agent.velocity.square magnitude variable. This variable contains the current speed of the agent. If this variable has a value other than 0, the agent is likely moving. By using the OR operator, either condition may be truthy. So, if the agent doesn't have a path but still has velocity, this condition will evaluate as true. Let's say all conditions end up failing. At this point, the agent has reached their destination. We can safely proceed to the next step. Open the return file. Scroll to the bottom of the update state method. Let's create a conditional statement with the following condition: enemy.movementComponent.reached_destination. The condition will be the method we've created. If this method returns true, we can begin transitioning into the patrol state. However, we should confirm the enemy has patrolling capabilities. Keep in mind, this state affects stationary guards too. Let's add a nested conditional statement with the following condition: enemy.patrolComponent!null. This condition is familiar to us. It'll check the patrol component variable for a value. As long as it's not empty, we can assume a patrol component was found. Inside this block of code, call the enemy.switchState method with the enemy.patrolState variable. Next, add the return statement to prevent the method from running further. We're almost finished. At the moment, the patrol state variable will not transition into other states. The enemy will be permanently stuck in this state. Let's go back to the patrol state. Inside the update state method, we're going to transition into the chase state. As mentioned before, the enemy is going to keep an eye out for the player. If the player is within chasing distance, the player should be chased. We've already written the code for this. We can go back to the return state method to copy the first conditional statement. Back in the patrol state, paste the code inside the update state method. Let's try testing our game. Head back to Unity. Play the game. As usual, the enemies are moving to the starting point of the path. If we look in the console, multiple messages will get logged. Each enemy has entered the patrol state. Let's try moving close to an enemy. The enemy will chase us as long as we're within the chasing distance. If we evade capture, the enemy goes back to the patrol point. Great! We've successfully transitioned in and out of the patrol state. Let's keep working on the patrolling behavior.